Hey guys, today we are going to start graphing our rational functions. So today we're really just going to focus on the reciprocal function, which is part of the family of rational functions, but it is when we have a constant in our numerator. So we do not have variables in our numerators yet. We'll have those tomorrow. I know you guys are so excited for that. Rational functions, remember, have division with variables underneath, and we have those two rules in math where we cannot divide ever by zero. So you can't even root a negative, and you cannot divide by zero. So if you see a function that has an even root with a variable inside, you're going to have restrictions. Same thing if you have division. So fractions are just division signs. So this is dividing here. So we should know automatically that x can never equal zero. So because x can't equal zero, we have these lines that we can't touch that are called asymptotes. So you'll see the function approach those lines, but never touch them. Our transformations of rational functions look a lot like our transformations for every other function that we've looked at. So a becomes the stretch or the compression in the function. Remember, if there's a negative a, it's just going to flip. So instead of your function being top right, bottom left, if you had to graph it and it was a negative a, it would look like this. It'd be bottom right and then top left. We will do examples, so don't get too overwhelmed. So H is just that horizontal shift. Remember, since there is a negative in our formula before the H, we are thinking opposite. So the positive H is moving left and the negative H is moving right. K is outside of the function, and that's the vertical shift. It's moving us up and down. So then we have two types of asymptotes. We have our horizontal asymptote, and that happens when there is a y equals k. So it's a whole horizontal line. So we want to make sure we have the y equals, and it's just going to be y equals whatever number is outside the function, that k. If there is no number there, then it's just going to be y equals 0. Your vertical asymptote is going to be whatever makes this denominator undefined. So it's going to end up being x equals, same thing, you need the x equals because it's the whole line, and it's just going to be x equals whatever h is. So since our domain is our x values, we're going to switch, sorry about that. Domain is our x values, so we are going to include all values except for that one where there is the asymptote. So domain is your x, range, remember, is your y, and for your y, you're going to include everything except for your k value. So you're going to skip over pretty much your asymptotes. I hope that makes sense. I guess this K technically should be green to go with my theme, but you guys know. You're so smart. So, all right, so let's look. If my parent function is y equals 1 over x, or f of x, the function of x equals 1 over x, then anything different than this would cause a transformation. So here I see this -3 in here. It is inside, so I'm thinking opposite. So this is actually telling me that h is +3, which means I'm going to move my function right 3. So my vertical asymptote here is going to be x equals 3. So I'm going to go 1, 2, 3, right 3, and I think of this kind of like an electric fence because you can get close to it, you just can't touch it. So there's my asymptote. Your horizontal asymptote is your k value. Here I don't see anything there, so I'm going to say k is 0. So since there's nothing there, it's not shifted up or down, and my horizontal asymptote is y equals 0. So there's my electric fence, or my asymptote there. So now let's graph it. So where those two asymptotes intersect, if this is a 1, and guys, you do not have to be perfect on this. We are just exposing you to information and hoping you can pick things up. At this point, we do want you, to use your critical thinking. So if you want to make a table of values, you can. But your first point is simply going to be over 1, up 1 from that intersection of those asymptotes. And then you just want to sketch it so that it approaches each asymptote. So this is a positive a value. Remember, this is my a. And since it's positive, you're thinking top right, bottom left. So here's my intersection again, 3 and 0. So I'm just going to go 1 away. So in other words, like left 1, down 1. And then I just want to graph my line approaching those asymptotes. I don't want to cross them. Let me move that. Okay. But I do want to graph it. All right, so domain. Domain are my x values. So if I look at the x values, I'm going to go left to right. That's an L. Left to right. So this one is going negative infinity up into my k value, which was 3. So I'm going to skip over 3. And then it's the union of 3 positive infinity, because then it keeps going to the right. These parentheses here, remember, tell me just to not include 3. So it's a skip, and that's a U. So when I look at my range, I'm going to look at my Y values. So I want to go from bottom to top. You can turn it, but this again, smallest to largest, negative infinity. It doesn't include 0 because there's an asymptote there, and then 0 to infinity. All right, let's look at example 2. So this time, still, A has not changed. A is just 1. If I look at my H value, H is actually positive 4. Sometimes it just gets wonky. Sorry, guys. So H is positive 4, which means I am going right 4. This one does have an H value. Sorry, a K value. This is K of 2. So the number outside is your K, and that's going to move me up 2. So when I graph this, I'm going to put a vertical asymptote, 1, 2, 3, 4, right 4. Don't touch this line. This is my electric fence. So x equals 4 is a do not touch asymptote. Up 2 means it's going to be right here. All right, so the intersection, let's talk about that one. Y equals, go back please. There you go. Maybe. All right. Y equals 2. So they're intersecting at 4, 2. So when I graph, I'm just going to go over 1, up 1. There is, sometimes they call that an anchor point, and then I want to approach both my asymptotes, left 1, down 1, and same thing. Kind of get really close to the asymptotes, just never cross them. If I'm talking about my domain is x values, so negative infinity, skip over 4, and then 4 to positive infinity. My range, I'm going to look at my y values, so negative infinity to 2, skip over 2, and go to positive infinity. Okay, why don't you guys try these next 2 before I do them? So just pause it, try it, then check it. All right, so hopefully you tried them. A is positive 1. This down here is my H. So H is actually negative 3 because I'm thinking opposite. So this time I am going to go left 3. So I'm going to take my vertical asymptote and make sure I do not cross x equals negative 3. Okay, if I look at my K here, K is negative 4. I do not think opposite for that, so this is going down 4. So my horizontal asymptote is going to move down 1, 2, 3, 4. There's that. Okay, now let's graph it. So I just want to, they're intersecting at negative 3, negative 4. So over 1, up 1 is an anchor point. And this should really look curved. So I know it's kind of hard to see on here, but hopefully you can check these using Desmos or your calculator because they look more curved than they're looking up here. So it kind of makes like shape like that. Okay, so domain. Domain, I want to make sure I'm focused on my x-axis. Again, I want to go left to right. So this is going to skip over negative 3. So all real numbers except negative 3. My range is going to be all real numbers except negative 4. So there are those. Okay, how'd you do on the next one? So the next one, I have a negative. So remember that negative flips it. So instead of being top right, bottom left, now I'm going to be bottom right, top left. So it flips that function over the x-axis. So this is reflected over x-axis. All right, then we have a k-value of 2. So that means I am moving right 2. 1, 2. I know it's a negative, but we think opposite since the equation have an x minus. So that negative tells us think opposite. So that's right 2. So that means my vertical asymptote is x equals 2. When I look at my k value, k is negative 1. So my last transformation would be it's moving down 1, which means my horizontal asymptote would be y equals negative 1. Okay, please don't do that. All right, so there's my electric fences. So now instead of going right 1, up 1, I am flipped. So I'm going to go right 1, down 1. There's my anchor point. You can, if you want to, Google what happens when that A is actually a number other than 1, like when it's 2 or 3, you'll kind of see the stretch. I don't want to stress you guys out right now with that. So we're just going to keep them as 1s. But my domain, all real numbers except 2. And then finally, my range is going to be all real numbers except negative 1. So that's the gist of graphing rational functions, day 1, which are reciprocal functions. All right, here are 2 more that we are going to look at in office hours, although some of you are very eager for me to try them. So on the next slide, so pause it, go ahead and try it. And then on this slide, you can go ahead and check your answers. So after you try it, come back here and then check your answers. I hope that helps. Please pop in office hours. See me every day, Monday to Thursday, 2 to 3. Miss you all. Bye.